Right, so one of the most obvious features people notice when they come to places like the Grand Canyon are the thousands of feet of rock layers that we have here. Now, looking at the Grand Canyon, we have about 4,000 feet of those sedimentary, water-laid rocks found present here at the Grand Canyon. Now, the question is, how did those rocks form? How did they get here? Now, to understand that, we can't use the present-day observational processes necessarily because we weren't there when the rocks formed. I can tell you a lot about a rock if I take a look at it. For example, this piece of limestone here, I can tell you how much it weighs, I can tell you the color of it, I can tell you the physical and chemical composition. You know what, I could even tell you what it tastes like if you want. What I can't tell you though is how that rock got here unless I was here to see it form. But based upon what we see today can give us a clue as to what has happened in the past. When we take a look at these rock layers, when we begin to examine them, it begins to tell a story. The rocks cry out, and they tell us a story of major catastrophic events like a flood in Noah's day. For example, looking at these rock layers, thousands of feet of sandstone, limestone, mudstone, siltstone, and shale are found present here. Now, to understand how they got here, we go and take a look at the rocks, and we examine them. Looking at these rock layers, one thing that stands out to me very striking is the flat knife edge boundaries between these rock layers. Now, when the common understanding of how the rock layers were formed would tell you that, well, typically they would say the oceans moved over the continents. For millions of years, sediment slowly accumulated in the oceans, slowly fell to the ocean floor, slowly stacked up some sediment layers, and then the entire ocean moved off the continent. And then that process repeated advance and retreats of oceans across the continent of North America, perhaps up to 17 different times, bringing in different layer groups that we see here, for example, like at the Grand Canyon. Now, one big striking feature to me says that is not the case of what has happened here. For example, like I said, these flat knife edge boundaries do not show us major signs of erosion on the surface of these landscapes. So if this was a top at one point and a new layer was waiting to come in on top of it for millions of years, the top of this layer should be dry, solid rock, and you should see tremendous amounts of erosion on the surface of that landscape. Each of these layered groups we see here should have a highly eroded surface. For 5 to perhaps 15 million years, they sat exposed to the elements. Now, for 5 to 15 million years, we should see all sorts of rain, valleys, channels, gullies, all kinds of eroded surfaces take place, so that when new sediment came in and stacked up on top of that, it should preserve that highly eroded surface. We should not find flat knife edge boundaries in between these layers. They should have highly wavy eroded surfaces. But you look at the canyon for yourself, you can see flat knife edge contact points and boundaries here. No major signs of erosion, especially over millions and millions of years. It's as if these layers came in rapidly and were laid down one on top of each other very, very quickly. For example, like we would see during a flood. Tremendous amounts of sediment layers dragged across the continents by huge tsunami-like waves, by tidal action and flow, stacking up layers like pancakes very, very quickly. Another thing we're missing, not only is all the erosion, but what's growing on the surface of this layer at the top right now. On top of the Kaibab limestone at the rim rock of the Grand Canyon, we have tremendous forests and ecosystems where plants and animals are living. We have bioturbation where plants and animals are churning and mixing up the soil. Now, we should find at the top of each of these layer groups a tremendous amount of sediment that has been churned up, that's been mixed up. We should also find plants and animals that were living and were buried there. Each of the layer groups we see here at the top should have some kind of ecosystem, some kind of forest ecosystem buried on top of it. But it's not present. It's as if, again, these layers were laid down rapidly, one on top of each other, stacked up very, very quickly. The kind of process you see from a global flood event. The canyon here tells us and shows us physically this happened quickly. This is not the product of millions and millions of years of slow accumulation. This is the product of layers happening very quickly. The same sort of processes, the same sort of features, the same sort of mechanism we would see from a flood in Noah's day.